Today we're going to be talking about monomials. So our unit 6, the first thing we're going to talk about is adding and subtracting, and then multiplying, and then the power rule. So the first thing that I want to look at is a monomial. So let's define it. A monomial is a number, a variable, or a product. Remember, product means multiplication of number and variables. So some examples: 5x. That's a number and a variable, right? Number is 5, the variable is x. 3x squared, the number, remember then this number is also called the coefficient, so 3 and then x squared. These are all called monomials. 9x squared y to the 7th. Do you notice there's no adding or subtracting in the middle of it? This is all multiplication. 9x squared y to the 7th. And then negative 5 halves x y to the 4th. Notice there's no adding or subtracting in the middle of this term and this term. It's negative, but there's no adding or subtracting. Negative 6 over 11, that's also called a monomial, and negative 4. So you get the picture. It's just one number, and it can have a letter next to it too, a variable next to it. It can have multiple variables next to it. These are all called monomials. So monomials with the same variables and exponents are like terms. So if they have the same variables, for example, for number 1, if we look down here, see how they have an x and an x? That means we can combine 17 and negative 25. Do you see down here how y squared and then y squared? Those are called like terms. So when you have a like term, it just means that the variables here are the same and we can combine the numbers in front. So when we add or subtract monomials, we have to combine like terms. Do not change the variables and exponents when you're adding or subtracting monomials. So we're not going to change the variables. We're just going to solve the number. So watch. 17x minus 25x. Those are like terms because they have an x next to them. So we're just going to do 17 minus 25. 17 minus 25 is negative 8, and we're just going to keep that x. We do not change the x. And we're used to adding and subtracting with x's. But over here, you see how there's negative 23y squared plus 6y squared? Y squared, y squared, those are the same. So we can combine these two, negative 23 plus 6, that's negative 17, and we're just going to put the y squared on the end. Okay, we're just saying if we have negative 23y squareds and we have positive 6y squareds, that means we have negative 17 of this term of y squared. So if we look at these examples, the first piece, do you see how this negative 15, a cubed bc, plus 6, a cubed bc. Do you see how a cubed bc, these are the same. So we're just going to say negative 15 plus 6, which is negative 9, and we're going to tack this big thing on the end of it. So we're going to say negative 9, a cubed bc. And that's it. Look at number 4. So number 4, you notice how there's 38. See the x squared y, those are the same, so we can combine these terms. Remember, when you don't have a number in front of the variable, that number is just a 1. So we have 38 minus 1. 38 minus 1 is 37, and then we're just going to tack x squared y to the end of it. 38 minus 1 is 37, and then x squared y. We're just going to put that at the very end. Number 5. I want you guys to try 5, 6, 7, and 10. We're going to do 8 and 9. So let's look at number 8. So we have CD to the 3rd power and we have CD to the 3rd power. So we can combine these terms. But remember, we have two negatives like that next to each other. What does that turn into? This turns into a positive. So don't forget that that's really a plus. And now we're going to say negative 9 plus 2, which is negative 7. And then we're going to tack on this at the end, CD cubed, because they both have CD to the 3rd power. Okay, look at number 9. What are like terms here? So notice we have 13w squared, 9w, 4w squared, negative 31w. So we have a w squared and a w squared, and then we have two w's, right? So we can combine the w squared terms. 13w squared plus 4w squared. Well, 13 plus 4 is 17, and we're going to put that w squared on the end. And then we have 9w minus 31w. And that's going to be negative 22w. We cannot combine those because, look, one's w squared and one's w. Those aren't the same, so we're just going to leave it. That's our final answer. Okay, so I want you to try 5, 6, 7, and 10. So now we're going to look at multiplying monomials. So this was adding and subtracting. Okay, when we multiply, notice there's no adding or subtracting in the middle of these terms, right? It's just multiplication right here on all of these. On these over here, we had adding and subtracting to separate these different terms, right? So here, we're going to use something called the product rule. So to multiply monomials, use the product rule. The product rule is x to the a power times x to the b power, which is x to the a plus b. All we're doing here, do you see how the x stays the same here, so it's still x, but you notice how we're adding a plus b? So let's look down here at a real example. We have an x and an x, right? According to the product rule, and product, remember, means multiplication. When they're put together like this, right next to each other, that means they're multiplying. So x squared times x to the third. Well, we can add 2 plus 3. So it's going to be x to the 2 plus 3, which is x to the fifth. 2 plus 3 is 5. Okay, and that's it. What about this next one? So notice here we have a to the ninth and a. Remember, if there's nothing above, there's no exponent above here, what is it? It's just a 1. Okay, so we have a to the ninth times a, so it's a to the 9 plus 1. A to the 9 plus 1, because we have 9 plus 1 here. There's a 1 here, so a to the 9 plus 1. So that's going to be a to the 10th. So here, x squared times x to the third, you add them together, x to the fifth. A to the 9 times a to the first power, a to the 10th. W to the 7th times w to the 4th power. What do you think we're going to do with 7 and 4? We're going to add them and write that answer. So I didn't realize I'm going to have you guys do number 13 and 14, okay? So you're doing the same thing. Try the product rule. Okay, so if we have coefficients, by the way, I would try the problems that I'm giving you before moving on, because I know there's kind of a lot in this, but I think once you practice with it, it's not too difficult. It's just a lot of rules. So you're going to have your notes with you. So just look back at your notes when you get confused, and I'm going to give you just a few to practice at the very end, and they're going to all be mixed. So that way you can kind of see, oh, okay, this rule goes with this, and so on. So let's look here. To multiply monomials with coefficients, what is a coefficient? Remember, a coefficient is just the number in front of the variable. So for example, 3x squared, that 3 right there, that's called a coefficient. So it's just the number in front of the variable. So to multiply monomials, remember each of these are monomials. Mono means 1. So to multiply monomials with coefficients, with numbers in front of them, you're going to first multiply the coefficients, multiply the numbers, and then you're going to simplify. So let's look at number 15. 4x squared times 3x to the fifth. So this is the same thing as the last page, except we have 4 and 3 this time. Instead of just x squared times x to the fifth, we have a 4 and a 3. So the only difference here is we're going to multiply 4 times 3, which is 12. And then x squared times x to the fifth, remember you add those, 2 plus 5, so 12x to the 7th. Number 16, we have 3 times 5, 3 times 5, which is 15, x to the, and remember we have a 6, x to the 6, x squared, remember we add those two, 6 plus 2, so it's 15x to the 8th. All right, I want you guys to try 17 and 18. Number 19, we're multiplying again. Negative 7 times negative 4 is a positive 28. Then we have p to the 9th times p squared. So remember, we have a p here and a p here. We have 9 plus 2, which is p to the 11th. Then let's look at our q. So q to the 3rd, q to the 6th. 3 plus 6 is 9. Let's look at our r's. We have r to the, don't forget, if there's no number up here, it's 1, right? We have 1 r here. And then we have 4 r's here. So 1 plus 4 is 5. Let's do number 20. So 20, notice there's a 1 in front of that AB. So we have 1 times 6 times negative 1, right? We're just looking at the numbers in front. 1 times 6 times negative 1. Well, 1 times 6 is 6. 6 times negative 1 is negative 6. Then let's look at our A's. We have an A to the 5th, and we have another A. So 1 plus 5 plus 1 is 7. Now let's look at our B's. So we have 1 B here, another B, and another B, so we have 3 B's total. So B to the 3rd. Okay, I want you guys to try 21 and 23, and we'll do 22 together. So fractions, remember multiply. We have negative 15 times negative 1/3. So that's going to, remember you put the 15 over 1, and we're just going to multiply across. So that's 15 over 3, which is 5. So now we know negative 15 times negative 1/3, these two, negative 15 times negative 1/3 is 5. How many x's do we have? We have x and x, which is x squared, 2 x's, right? Then we have y to the 4th and y to the 3rd. 4 plus 3 is 7. Okay, so the last piece that we're really going to learn today is called the power rule. And I'm going to explain how this is different. So do you see how this time it's x to the a raised to the b power? So instead, it's different from the last one because remember the last one we were, it wasn't raised to a power, right? We're just multiplying across, we're adding the variables, the exponents here. But in this case, notice it's x to the a and then it's raised to some power, b. So in this case, we're going to say x to the a times b. We're gonna, whenever we see something that looks like this, see all these examples right here, when it's raised to another power on the outside, we're going to multiply these two numbers. Whatever those numbers are. So a times b. We're going to keep the x the same. So you see how there's x squared and then raised to the 5th? We're going to say 2 times 5, which is x to the 10th. Now this is different than x squared times x to the 5th. In the last page, we wouldn't have had something that looked like this. We would have had something that looked like this, right? X squared times x to the 5th. Remember, you add 2 plus 5 here, and it's going to be x to the 7th. But up here, when we have x to the 2 raised to the 5th power, it looks different than this, right? Here we add them together when it looks something like this. When it looks something like this, we're going to multiply 2 times 5, which is x to the 10th. Okay, so they're different, and they look different, don't they? So like I said, this just takes practice. We're going to practice a lot with these. So I just want you to get the rules down. Okay, now we're going to do 25. So m to the 7th times n to the 4th raised to the 4th power. Do you see how this 4th power is out here? We're going to multiply. So it's m to the 7th times 4. And then we have n. We have n to the 4th times 4. Well, what's 7 times 4? 7 times 4 is 28. So we have m to the 28th. And 4 times 4 is 16. So n to the 16th. And that's our answer. Let's do 26. And then I'm going to have you guys do 27. So here again, we just multiply 3 to c. And we multiply 3 to d squared. So c, remember it has that 1, so we have c to the 1 times 3. And d squared times to the 3rd power is d to the 2 times 3. So we're going to multiply here. And multiply here. So this is c to the 3rd power and d to the 6th power. Okay, try 27. So we're going to use powers of monomials now with coefficients. Remember, coefficients is just the number in front of the variable. So the only difference here is we're going to multiply that 2 to each thing. So we're going to multiply that 2, this 2 on the outside, we're going to say 5 squared, and then x to the 7th squared. So you see how it's 5 squared? And then this is just like that last page. X to the 7th raised to the 2nd power is x to the 7 times 2. 7 times 2 is 14, so it's 25 x to the 14th. Okay, don't forget, when we're multiplying here, 5 squared is 25. It's not 5 times 2, it's 5 times 5. So this just means 5 twice, 5 times 5, which is 25 x to the 14th. Here again, we're just going to multiply that 5 in. So we have 2 to the 5th times x squared to the 5th. So x times x squared, right, 2 times 5, and then y to the 5th. 2 to the 5th is the same thing as 2 times 2 times 2 times 2 times 2 times 2. So 2 5 times. 1, 2, 3, 4, 5. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we have 32. So 2 to the 5th is 32. X to the 10th, y to the 5th. Okay. Okay, 30. You see how I'm going to multiply that 2 inside? So it's negative 2 squared. P to the 4th, so P to the 4 times 2, and Q to the 6 times 2. Well, negative 2 squared is negative 2 times negative 2. Negative 2 times negative 2 is a positive 4. P to the 4 times 2 is P to the 8th. Q to the 6 times 2 is Q to the 12th. Okay, now we're going to look at this next one. Notice here I multiplied the 3 into both, so it's negative 3 to the 3rd power. And then we have x to the 2 times 3. Okay, so negative 3 to the 3rd power is negative 3 times negative 3 times negative 3. Now look here, negative 3 times negative 3, negative times a negative is a positive, 3 times 3 is 9, so we have positive 9, and then times that negative 3 is negative 27. So negative 27 is an answer here. So 3 times 3 times 3 is 27, and then it's going to be negative because we have a positive times a negative here, which is a negative 27. And then x to the 6. Okay, I want you guys to try 32 and 33. And this is the last page. Last page. So I'm going to do, let's see, 34 and 35. And 38, and then I'm going to have you guys try the last ones, okay? So here, again, we're just multiplying in. So this 3 is multiplying here and here. So we have x to the 3 times 3, y to the 3 times 3, and then I'm just going to bring down this guy right here. I'm going to bring it down. So this is x to the 9th, y to the 9th, and then I'm going to bring down the xy squared. This is just the number on the outside, right? I haven't done anything to that. So now I'm going to, remember in the very beginning here, when we multiplied, we're going to actually add 9 and 1. So x to the 9th times x is x to the 10th. And then y to the 9th times y squared is y to the 11th. Okay, let's do the same thing for 35. So this is negative 2 squared. A squared, b to the 4th. How is it b to the 4th? Because 2 times 2. Times 3 squared, a to the 4th. How is it a to the 4th? Because 2 times 2 is 4. B squared. So let's multiply these numbers first. Negative 2 squared is positive 4. A squared b to the 4th. 3 squared here is 9. A to the 4th b squared. And now we can multiply. 4 times 9 is 36. And remember when it looks like this, when they're just next to each other and multiplying, we're going to add 2 plus 4, a to the 6th, and then b to the 6th. Okay, last one. Now look, we have addition. Oops, we have addition here. So let's look at these exponents first. So we're going to multiply here. We're going to multiply in. It's going to be 2 to the 3rd. And a to the 2 times 3, a to the 6. 2 to the 3rd is 2 times 2 times 2, which is 8, a to the 6th, plus, now I can multiply this, right? A to the 4th times 3a squared. Remember, I add those in. When it's just multiplication and it's not being raised to a power, I add. Okay, so 4 plus 2 here is going to be 3a to the 6th. Now look here, aren't these the same? A to the 6th, a to the 6th. 8 plus 3 is 11, a to the 6th. We can add those when we have the same variable here with the same exponent. So a to the 6th and a to the 6th are like terms, which means we can combine 8 plus 3 is 11, a to the 6th. We just keep the same when we're adding. Okay, so I know it's a lot of rules, but try the ones that we circled. If you don't understand, Ms. K and I are going to come around and help you.